All right, I think I'm live now. Can someone confirm in the chat if I'm live or not? I see many comments. Okay, I think I'm live. Can someone confirm? Yeah. Okay, cool. Okay, so let's start. Live, live. Okay, okay. I think I had the worst contest today. Okay, and I hate when the contests have many bitwise operations. But anyways, like I'll be solving ABC only because I haven't read D at all. Okay, 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 okay. Let me just open the chat, my monitor. Okay, can people tell me like how many problems they were able to solve today? Although we have a good submission count on C, but like I myself wasn't able to do 2 1 1. Okay, today's contest was very weird, I would say. So like at least for me, so it's okay. Like if you weren't able to solve many problems today. Okay, I don't think I can read all the chart. Okay, okay, 0 0. Okay, almost already. That's good. So that's really good. See, bata do. Okay, let's start. I'll be starting with problem A only. I'll start with A, B, C, and C then. Okay, so let's start with the very first one. A and B are pretty easy, I would say. But C is also like very easy. Like the second I read the answer, like I was like so much confused, like why this is happening. But yeah, okay. Okay, all right. Let's start. Okay. So the first question says that okay, this recently the students of school 179 have developed a unique algorithm which takes in a binary string s as input. However, they soon found out that if some string t of s is a palindrome of length greater than 1, the algorithm will work incorrectly. Can the student somehow reorder the characters of s so that the algorithm will work correctly on the string? Binary string is a string where each character is either 0 or 1. Okay, so basically what they're telling us is that we are given a string. Let's take the very last one. We have 0 1 0 1 and 0. Okay, now if the string is 1 0 1 0, is there some way we can reorder such that there are no palindromes in it? Because if you see, we already have a palindrome as 0 1 0 or 1 0 1. And if you see, there is no way we can actually reorder this such that there is no palindrome, because if we make 1 1 0 0, or if we make what, I think that's the only string we can make. We can make 0 1 1 0. In this, these two are a palindrome. In this, these two are a palindrome. These four are also a palindrome. Okay, so there is no way you can actually get a string which does not have any subarray as a palindrome. So the answer for this one is no. Okay, let's try to make any string with length 3. So if the length of string is 3, okay, what if all of them are 0? Okay, camera lagging. Is that so? Okay, what if it is 0 0 0? What if it is 1 1 1? What if it is 1 0 1 0 1 0 1 1 0 0 1 1 and something else? If you see, there is no string with length 3 which actually isn't a palindrome, or a part of it is not a palindrome. Okay, now let's come to length 2. For length 2, if you see, we have 0 0 1 1 0 1 1 0. Okay, and if you see, all good, no? Okay, if you see, this is a palindrome and this is a palindrome. So only these two will actually give us a yes, otherwise these two will also give a no. And for length equals to 1, if length is 1, we can either have 0 or 1, and both of them are not a palindrome because a palindrome has to have a length greater than 1. So there are 4 cases actually. If the string is 0 or 1 or 0 1 or 1 0? Then the answer is yes, otherwise the answer is no. Okay, and that is all you had to do in this problem. So I'll quickly show my solution as well. Okay. Opening. Yeah, okay, cool. So what I did was if s is equals to 0 1 1 0 0 or 1, I just print yes, otherwise I print no, and that's it. Okay, I think more everybody was able to do this problem. Nothing much. I just had to figure out these cases, and then all you have to do was write some code. Okay, cool. Let's move on to problem B then. Another easy problem, I would say. Okay, so what the problem says is that it has finally been decided to build a roof over the football field in School 179. Its construction will require placing n consecutive vertical pillars. Furthermore, the headmaster wants to the height of all the pillars to form a permutation p of integers from 0 to n minus 1, where pi is the height of the ith pillar. Okay, cool. So basically, we have some pillars. Okay, we have some pillars, and every pillar has a height pi. Okay. Now, these heights have to be a permutation from 0 to n minus 1. Okay, as a chief, you know the cost of construction of consecutive pillars is equal to the maximum value of the bitwise XOR of heights of all pairs of adjacent values. In other words, the cost of operation is equal to maximum of pi XOR pi plus 1, where XOR, this operation denotes the bitwise XOR. Okay, so screen is blur. Is that so? I think now it won't be blur. Okay. Okay, cool. So, okay, let's take a test case. Let's say n is equals to 5. If n is equals to 5, the given solution is 3, 2, 1, 0, 4. Okay, let's write the XOR value. So 3 actually means 1, 1, 2 actually means 1, 0, 1 is 0, 1, 0 is 0, 0, and 4 is 1, 0, 0. Okay, now XOR of these two values is actually 0, 1. Okay, XOR of these two values is 1, 1. XOR of these two values is 0, 1, and XOR of these two values is actually equals to 1, 0, 0. I think I missed something. Is 3, 2, 1, 0, 4? Cool. Okay. So if you see, okay, if you see, this actually means 1, this actually means 3, this means 1, and this means 4. Therefore, the answer for this one is 4. That 4 is the maximum XOR value with this permutation. Okay, if you try to take any other permutation, it will either have a maximum value of 4 or greater than that. Okay. Now, how to do this question? So actually, the way I did this was, what I did was, and it's a pretty neat trick. You can actually use it in many contexts. What I did was, I actually made an array from 0, 1, 2 till n minus 1. Okay. And then I wrote a brute force approach in which I'm actually making all the permutations of this array, finding the XOR of all the consecutive pairs. Okay. And then looking which value is the maximum, and then printing only those permutations which have the maximum value. Okay, and after that, like, I was actually able to come up with a pattern, and then I just coded that pattern. So in this like right now, I'll actually try to explain like why that pattern works. Okay, so okay, let's say, okay, I'll just quickly show my complete board. Let's say n is actually equals to 10. Okay, now for this, you can actually make an answer as 7, oh sorry, 6, 5, 4, 3, 2, 1, 0, and then 8 and 9. Is this clear? Okay, now I'll explain like why this is working. Now, if you see, using this, okay, what does 8 have? 8 actually has 1, 0, 0. Okay, this is the binary representation of 8. Okay, what if I had used this 8 with this 7? If I had, or in fact, any of these numbers, if I had used this 8 with any of these numbers, the bitwise XOR of this 8 with any of these numbers would be something greater than 8 only, because none of these values have 1 at the fourth index. Okay, but they have some ones at some other indexes, and those will actually add up to this answer, and hence it will give you a value which is greater than 8. Therefore, it is best if you take this 8 with a 0. Okay, and using that, you will actually ensure that your answer is not greater than 8, or actually it is equals to 8. Okay, is this clear? Because if you use this 8 with anything ex except this 9 or anything like smaller than 8, okay, you'll actually get something greater than 8 only, because this 8 has 1 0 0 0 and all these values have bits set as 1 in any of these indexes. Okay, but after this 8, every value has this one also. Okay, so if you take like XOR of 8 and 9, 9 is actually 1001. So this index is 1 and this index is also 1. So both of these will actually give you a 0. Okay. So now, like in questions like these, you actually have two options. Either if you're able to come up with the solution in a minute or two, okay, you can actually just print that. Otherwise, what you can actually do is you can actually just find, like, make a brute force approach in which you print all the permutations which have the maximum answer, okay, and then just try to find a pattern, because in these type of questions it is usually a pattern only. So basically what you had to do was, if your n is something like, say if n is 20, you had to find out the value which had the last bit set. Okay, so basically that is 16. Okay, which is the power of 2. So we have 16. So what you had to do was print all the values from 15 till 0. Okay, then print from 16 till n minus 1. Okay, so I'll quickly show you my code as well. So this is what I did. Okay, so what I did was I just made a vector of power 2 in which I'm actually inserting 1, 2, 4, 8, 16 and such. So then I found out the power of 2 which is just less than n minus 1, or less than n actually. Okay, when I found out that index, so basically if n is 20, I'm actually searching for this 16. The second I found out this 16, what I'm actually doing is I'm making a I'm starting to print from n minus 1 till index. So basically I first printed n minus 1, then n minus 2 till 16. Then I printed 0, okay, then 0, then 1, then 2, and this. So basically I'm actually printing the reverse of this array, okay, or you could have the reverse of this. Both are same only. Brute force, wouldn't that be TLE? I actually did that brute force for like n equals to 6 or 7, okay, and with that I was actually able to see all the patterns for all the, like for all n's, and then I didn't submit the brute force. I just used that to find the pattern. Okay. Blurred, is that case for everyone? Like, is the screen blurred? Okay, got it. Okay, what if we print from 1 to power of 2 minus 1, then 0, then print 2 n minus 1? I am not able to get what you're trying to say, Aditi. Okay, cool. Ayush no, Pratham no, Himanshi no, Aditya no. This no is for like, are you not able to understand like why this is working? Okay, that is for the blurred screen. Okay, no way, all good. Okay, cool. Okay, I think it's time to move to problem C. Okay, okay, cool. Change test. And this question actually reminded me why it is very necessary for you to actually read the complete problem statement, because I actually missed something in this statement. Okay, and I'll tell you like what I missed and what I was actually trying to do. Okay, Igor is in 11th grade. Today he will be have to write an informatics test by the strictest teacher in the school. Igor knows how the test will be conducted. First of all, the teacher will give each student two positive integers, a and b. A is less than b. After that, the student can apply any of the following operations any number of times. Okay, so the three operations are either he can increment a by 1 in one operation, or he can increment b by 1 in one operation, or he can actually make a equals to a bitwise or with b. Okay, and to get full marks on the test, the student has to tell the teacher the minimum required number of operations to make a and b equal. So we have three kinds of operations. Either he can make a equals to a plus 1, or he can make b equals to b plus 1, or he can make a equals to a bitwise or b. Okay, cool. I'm actually getting some generic questions like what are all the topics in these. I'll actually answer all these questions in the end. So like you can ask all such kind of questions in the end of the stream. Okay. All right, cool. How to do this? Okay. Now, if you see, there is this mentioned and actually bold, it is guaranteed that sum of b over all test cases does not exceed 10 to the power 6, which actually means that you can run a loop from 0 to b for all the cases and it won't give you a TLE. And this is something I missed, and hence I was actually trying to come up with solutions which actually, instead of using the complete number, I was actually just looking at the binary representation of the numbers and trying to find a way through which I can find the most optimal like way of making the operations. But instead what you had to do was, okay, I'll just quickly show my complete board. Okay, so we know that a is less than b. Okay, let's say this is a number line, this is 0. Okay, somewhere along this line we have a and somewhere along this line we have b. Okay, now let's try to make this a equal to b. Okay, let's say we are trying to make this a equal to b. In order to do that, what are all the possible options? Either we can directly, okay, so basically, and we know that making an OR of a with b does not actually make it equal to b. What we instead we can do is, let's try to add some value. Let's say we try to add some x. Okay, if I try to add x in a, okay, so how many operations have I used? Operations that I have used are, I've already used x operations. Okay, then after this, I assume that a plus x is, if I take this OR of bitwise OR of a plus x with b, it will actually become b. Okay, so for taking an OR, I have 1. That's it. Okay, so basically what I assumed was, what I was trying to do was, I'm trying to bring this a equal to some particular x first, and then I'm just taking if bitwise OR of this x and b is equals to b. So basically what I'm actually doing is, let's say this is I, and I'm actually just adding x in it. So what I'm doing is a plus, okay, let's say this is x only, and I added I value. So I added I values. My new number is a plus I, and I'm trying to see if a plus I or b is equals to b. If that is the case, the number of operations I need would be I plus 1, because I was the total additions I did in a. Okay, and 1 is for making this OR. This is one case. The other case is, what if this x is actually after this b? That means I had to add some values in b. Instead of adding some values in a, I had to add some values in b. Okay, if that is the case, if my x was somewhere here, what I had to do was, I first had to increment my b to x. Okay, so let's say I again had to like increment only I values. Okay, so I incremented I values. Now my new b is actually equals to b plus x, sorry, b plus I. Okay, and now I have to see if this b plus I, when taken a bitwise OR with a, actually becomes equal to b plus I, because my new b is b plus I, which is actually equals to this x. If after adding some values in this b, if I'm able to get bitwise OR of this value and this a equal to this value, that means I only had to make I operations for the addition and then one operation for the OR part. And these are the only two conditions that you had to see, because this x can either exist between a and b, or it can exist somewhere after b. No other case. What will be the limit of b plus I? Actually, what you have to do is, the very first I which you get, for which this condition is true, you can just break out of the loop. Okay, and as you can see, like since this is bitwise only, this value will be less than, this x will be less than 2 times v. Why is this optimal? The reason this is optimal is because you're actually just finding the smallest value which you need to add in I, which you need to add in a, to make the bitwise OR of this new value equal to b. or you're trying to find out the minimum value that you have to add in B such that the bitwise OR of the new value and A is equals to this new value. Is X greater than B? How can X mod B equals to B? No, X mod B is actually going to be equal to X only. I've written B plus I here. भैया कोई टिप्स दो ना, सिर्फ ए और बी ही सॉल्व हो रहा है, आगे बढ़ ही नहीं पाते. It's okay, like you just have to practice. Like I myself was able to solve A and B only today because I kept on thinking about some decimal representation of these numbers and finding a way, but it was a very brute force kind of approach. One or two could possibly add some time in A and then in B. No, that is not possible. That you add some values in A and some values in B, because you can actually take those values of B and just add them in A. Okay, both of them will actually mean the same thing. What if I add X in A, Y in B simultaneously, achieve the solution optimally? If you actually see, if you are able to achieve a solution, okay, how do I explain this? Bhaiya, will there be X? Okay, let me try to explain this comment. Like, what if I add X in A, Y in B simultaneously and achieve the solution optimally? So, okay, let's say my A was something 101001 and my B was 101001. Okay, or let's say these two are also 1. Okay, now, okay, let's have this way. If this is 1 and this is, okay, no, this is 0 only, this is 1. Second, this is 1, this is 0, this is 0, this is 1. Now this is A and this is B. Okay, now in order to make A equal to B, okay, what you can actually do is you can have, like, you just have to add, like, what you are trying to do is you're trying to add some value here and some value here. Now I'm actually trying to prove that there is no need of adding some value in this, because the only reason why you're adding some value in this is just to make this index equal to 1. But that you can actually do just to make, okay, yeah, this index equal to 1. That you can do. You added some value X in this B such that this 0 becomes 1. But there is no need of adding some values in this one. Okay, because you can actually do that using bitwise OR. And after taking bitwise OR, this 0 will become 1 only. Problem. Okay, so this was problem C. Is there anyone who is still not able to understand problem C? It was a very easy question, I would say, if someone had like read the constraints properly. A simple BFS is also working on this. BFS is working on this. Okay, if like BFS is working on this, then yeah, actually BFS will also work, because actually in BFS you are trying to do this thing only. In every operation you are, okay, is BFS working? That is interesting. Okay, let me show you the code. I haven't showed the code. Okay, so this is the code. What I'm actually doing is I have A and B. I scanned A and B. Now my first possible answer would be B minus A, that I didn't take any bitwise OR. I just added some values in A such that it is equals to B. Okay, so this is my, like, the basic case. Okay, then what I'm trying to do is I'm actually running a loop from I equals to 0 till B minus A, I plus plus. Screen is blur. Is that the case? I don't think that's it. Like, that's the case. Okay, now, okay, I think this is right. Okay, so this is how you're gonna do. The very first case is if my final answer is actually equals to B. So I'm trying to add some value in A. So that value is I. If I try to add some value in A such that it becomes equals to A plus I. Okay. Now, if the bitwise OR of A plus I with B is equals to B, that means I only had to make I operations for the addition of values and then one operation for the OR. So this is one case. And the other case is, what if my final value is equals to some B plus I? If that is the case, I had I operations just to increment the value of B, and then I had one operation to make the bitwise OR. Okay. Is this clear to everyone? Like why this is working and how this is working? Uh, the reason there is no limit in this is because, okay, you can actually make a limit also, like you can like I less than B, that will also work. Okay, but since I'm breaking at the very first case when this hits, I don't really need a upper limit. Okay, so we can just remove this. A plus 1, A minus 1, A or B, but three possibilities are there, and A minus 1, cause if I do B plus 1, it will increase difference between A and B is just same. Yeah, I think that's the case. Thanks for explaining problem B. Keep all clear. Okay, is ABC clear to everyone now? Because if it is clear to everyone, I think I can end the stream. I haven't read problem D, so I won't be able to discuss that. But yeah, that's all for problem A, B, and C. Okay, can we do it using a recursive approach and then memorize? Yeah, you could do that, but I'm not very sure like if that will work. So if you're trying to have a recursive, okay, so basically you're trying to have a basic DP of what? Yeah, that will also work. You're right. That will also work. So basically what you're trying to do is for every value between A and 2B, I would say, you have two cases. So yeah, that will also work. How will BFS work? The reason I don't know if like straight away BFS will work or not, but if you do memorization with BFS, it is going to work because that will actually mean dynamic programming. So basically what you'll do is you are at A and you have B. For every value X from A till 2B, you're trying to find the best possible way to reach X. Can you please give some roadmap for me? I'm at 950. If you are at 950, I would say like try to do implementation problems because that so that like you become fast at coding first. Okay, like if you are able to like just see the approach in a minute, think of the approach in a minute, you are able to do code that as well in a minute or two. Counted. The case of 5.8 in this new A slash B is counted. Yes, it is counted. Yeah, straight away BFS worked. Okay, I that's actually little strange, like why straight away BFS worked. I have a feeling that it might fail. Okay, if like the number of operations are, but yeah, if straight away BFS worked, that means it worked on the last test case as well. That means it is not going to fail in the system test. Okay, what are all the topics and questions I should do so I would be able to solve Div-2B at least? For till Div-2B, I don't think you need to solve any like topic. Okay, you just have to be able to solve implementation problems. You're still after 10 contests only able to solve A after 2 months practice help. That's okay. Like if like 2 months is not a very big time. Okay. So if you're able to do A, that's okay. But yeah, try to do more implementation and basic greedy problems. Okay, it will make you better at B, Div-2Bs. From A problem. How you think for solving A problem? What was problem A? Okay, that is like a basic intuition only. You can actually see, like, you are actually just when you try to write some test cases, you are able to see that there is no case of length 3. So there are only cases of length 1 and 2. Then write all the cases for length 2 and then see how many cases of this are going to give you a yes answer and how many of them are going to give you a no answer. Can we use DPNC? Yes, you can use that. Okay, I think that's enough for today's stream. We have a contest tomorrow as well. Education. I think it's in which round is this? Education round. Yeah, it's an educational round tomorrow at 8:05. So I'll probably start streaming at 10:30 today, tomorrow. Can you tell me the topic so that I could take problems like B in future? Just try to solve implementation problems. If someone uses DP, the constraint on A and B was 20, so memory limit exceed हो जाएगी क्या? No, there won't be any memory limit. Yes, भैया. Okay, cool. Okay, cool. Okay, if you like the stream, make sure to subscribe to the channel as well, and also do like the stream as well. Okay, and I'll see you tomorrow.